Thanks to PCBWay for sponsoring this video and providing these awesome looking PCBs. These are going to end up being the base plate for the robot we're about to build because I needed something light and strong enough to survive the weapon we're going to put on it. And I got a lot because I think we're going to break some. Hello everybody, I am Ben from Team Panic. So what kind of madness requires this level of preparation and redundancy? Well, this does. This here is the hi-jinx bar from Fingertech. It is a beautiful piece of laser cut steel, and yeah, I was on the Fingertech website, saw this and loved it so much I had to buy it. However, it is 77 grams and 6 inches in diameter, which is massive, and I want to put it on an ant weight, but that means basically making a very, very light ant weight and somehow managing to spin this blade. This is where these PCBs from PCBWay come in, because they give us a light yet rather strong base to mount everything to, and as you can see here, I actually have the brushless motor mounted directly to these PCBs. You'll also see some traces out the back here, but unfortunately we're not going to use these because they are components that should make up a brushed ESC. However, I have not been able to get this working. I have a test version of this on a regular PCB that could have been used in an actual robot or in another robot, and unfortunately have not actually got the code working for that. It seems the microcontroller that I'm running has some problems with interrupts, which for those of you out there who have done coding of RC gear, you'll know that interrupts are very, very important, and this microcontroller can't do that. So this was a bit of an aspirational goal, and unfortunately it is not going to be a thing. But that doesn't stop us from using this PCB for the thing it was intended for, which is of course holding the brushless motor and all of the components or all of the electronics that we're going to need to get this robot running. So being able to build this robot is going to be an exercise in penny pinching weight, or gram pinching, I guess I should say, weight every way possible. So I have basically done that. Normally I would run like an 1806 motor, but that's like 17 and a bit grams. I am going to run a slightly smaller motor. It is about the same. It is slightly less heavy. I'm probably going to trim the wiring back just a little bit more to kind of save a little bit more weight here. We'll probably drop another half a gram or so, which doesn't sound like a lot, but is going to be a lot in this particular context. Next up, we have drive motor. So this is a regular N20 drive motor, and as you can see, about 9 grams. But we're not going to be using an N20, we're going to be using an N10, which is just slightly smaller and means I save an extra gram on each motor, which is pretty good actually, as far as part substitutions go. Next up, I usually use these kind of 20 amp speed controllers, and again, you can see kind of like 4 grams there. I'm going to be running a 7 amp speed controller. So that is half the weight, and also, yes, this does have connectors and stuff on it for making it quick changeable. Everything here is going to be connected, hardwired. Everything is going to be just soldered directly as needed because, yeah, trying to sort out anything else is going to be too much weight, effectively. Speaking of weight though, the battery is the big one. It is about 12 grams, as you can see here. My homemade 2S pack that is a lot smaller is about 8 grams. So that saves 4, which is huge when it comes to doing all of this kind of stuff. Yeah, and then I'm also going to, again, like bare wire things up. So we're going to use a bare receiver and the smallest of everything else that I can get my hands on, basically. So, all right, I'm going to stack all of this on here and we're going to see how close we are currently. Oh, yikes, this is going to be close. That is 10 grams to put up walls and to put a lid on this thing, and also all of the wiring, effectively. Oh, also, sorry, I've left out the nut that holds the weapon on. So, yeah, 9 grams to put up walls and, yeah, get everything else sorted out. That's going to be difficult, but let's hit the printer. So it's taken just a little bit of printing to get the chassis here sorted out. Now, The black pieces that you can see are TPU and the green ones are silk PLA. So I printed them in two different materials because I wasn't sure what kind of flexibility or hardness I wanted out of these things. Yes, PLA isn't a great material for a chassis necessarily, but there's so little of this and it really shouldn't get hit, I hope. That it could be a viable option here. And interestingly enough, the parts are fairly similar. There's like a ½ gram difference between TPU and PLA in each of these prints. And in actual fact, PLA is lighter than the TPU, which is something I wasn't expecting, to be honest. I was expecting TPU to be a little bit lighter, I think mostly because ABS is lighter than PLA. Anyway, you can see a couple of different experiments here. So a bunch of these changed as things went through. So there are thinner versions of the back wall. So this is the back wall here. It sits on there. And then there are different versions of the front wall as well. This one is the thinnest, lightest version of the front wall. But even with the thinning and lightening of both of these parts, the two parts together are about 5 grams, which make up most of the extra weight that I had, which doesn't account for bolts or a lid or anything like that. And there's not very much space in here, so I do need a good tight lid because otherwise all my electronics are going to go a little bit wild. But we may actually end up with some weight for that, because as I was waiting for all of these parts to come off the printer, I did discover something. I was looking at some of my flea weight components. Now these are the N10s that I mentioned before. Let's take a look at that. They are just a shorter version of the regular N20s, and they have a really nice gearbox on them. A while back for fleas, I bought these, which are the same size motor as the N10, but they have a plastic planetary on them instead. These were a pain to use in fleas because the output shaft is tiny and like a Lego connection, but not a standard Lego connection, like a custom Lego connection. And I really didn't want to use these. However, they actually provide a significant weight bonus here. You can see 8.2 grams. If we then weigh these little plastic planetaries, 3.8 grams. This is a massive, ridiculous saving for this robot. So as much as I hate these gearboxes and I think they're going to explode in the first hit and they're a real pain to get a wheel on, a 10 gram saving effectively, or like an 8 gram saving across two motors, is a lot, especially for this particular robot. So it may be a case of sacrificing some drive power to allow the weapon to work in the first place. The next step is going to be to do the electronics, but to do the electronics, I actually need to know where everything sits down and how it all sits inside the robot. And to do that, I need an inside to the robot. So we're going to put this together as it currently stands. These are designed so that they will screw onto the PCB long enough for me to actually hold them down. Because as you can see, this is thin and floppy, and with 2 contact points, there's a lot of different places that it could actually sit. So we're going to screw it down and then glue it in place with some super glue, and then take the screws back out and finish gluing it effectively, just so that we've got those 2 contact points nice and ready to go. And then the wall should hold in place. And of course the lid itself will just screw into these screw points. This, by the way, is the other reason for TPU. TPU grabs really well when you print an actual thread into it, because it's a flexible material, so you just print a thread into it and the screw really grabs when you try and use it. Okay, I am pleasantly surprised by that. Is it straight? Not really. Is it accurate? Again, not really. Will it do the job? Actually, probably. So again, this is just like thin wall TPU, and off the thing, it is ridiculously floppy and bendy, but glued in place, there's a little bit of give. But that's about it. With the lid on, this should actually hold pretty well. Now, the other thing too I need to work out is, did I leave enough space? Yes, I did. Cool, my motors can actually sit in. Oh, and I haven't actually pinched them. Oh, I pinched on this side. Okay, cool. This is what it was supposed to do. It was supposed to like grip a little bit. This side, despite the fact that I thought I'd managed it on both sides, hasn't really. Like if I, yeah, no. So I might have to like add some foam or something to that side, but of course we are running out of weight everywhere, so adding is not easy at this point. And again, we actually probably won't use those, we'll probably end up using these. Those are different sized. Okay, that I should have looked at earlier. Well, I'm gonna try and not use these then, I guess, because they don't fit. Although I was planning on just gluing the motors in anyway, much like I've glued everything else in here, because I don't have the weight to really do motor mounting any other way. And I've been told that you can actually glue N20s down and have them hold, so maybe that will work here. So I don't normally speak too much about wiring on this channel because it can get a little bit repetitive and a little bit difficult to make look interesting on video. But I figured this one was such a interesting challenge that it needed to be talked about at least a little bit. So I'll kind of run you through what I'm doing here. Everything needs to have an exact place that it has to go so that the entire robot packs down properly. And that means that wiring has to be done a specific way. So for example, the brushless motor here has this ESC wired up such that when I get it in spot, and this will need to be under this, again, I've sorted out where everything needs to live. This goes in here and sits over this side of the robot, just like this. And that is wired in such a way that it literally cannot go anywhere else. And you'll also see that I have wired up my motors to a different ESC and switch at the moment. Oh, sorry, not ESC, receiver and switch at the moment, because I was making sure that my wheels were going the right way. Because in here, we actually have these little like red ESCs, which to my knowledge are made by the same person who makes the Malinky Nano. These are effectively a clone of the DF robot motor ESC, however they come separately so I could attach them to N10s. Also, you'll see that I have put a little bit of extra wire link between the N10 and the actual ESC. You can solder them straight on, however I am considering gluing these motors directly into the chassis, and I want to be able to salvage those ESCs because they are actually decently pricey, at least pricey enough that I don't want to just throw them away if this entire robot gets destroyed. So that's kind of where we're sitting on this. Like I said, everything basically has to have a spot, and I wanted to make sure that I had where these ones wired up before everything else was done, because that way I can now sort out where my receiver is going to go, and then I can cut wire links specifically so that the receiver sits exactly where it needs to and has no play at all. We're also probably going to have the battery over in this corner with power wires going over top, and battery going underneath. Like I said, this has all been relatively well thought out. There is just a few little hiccups yet left to sort out, including where the switch goes, which I think may end up having to be over here. And then I'm gonna have to run wires specifically to get to the actual output power. We need another plug for the battery to connect everything in. Oi, 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 this is a mess. And it is quite a challenge to get everything to sit down where it needs to and stay there. If we have any weight left over at the end of this, which is a big if, I will probably have to hot glue some stuff in place to make sure nothing in here moves. Because again, once everything is sat down, the HiJinx bar goes over top and it is going to be spinning like 3 mil above all of these electronics. so it needs to work, and nothing can move, basically. Well, would you look at that? This is probably the neatest ant weight I have ever built, mostly because things are designed or wired with exactly enough wire to go in just one spot and one spot only. There is very little room in here, so no real extra room for wiring. So we've soldered everything precisely, which is a little bit scary, but I guess we'll find out how we go. Now we need to move on to lid choice. So I've got a couple of options. I've got some HDPE from a milk bottle. I've got a takeout container, which is definitely like polyethylene or something along those lines. I know it's a little brittle. And then I've got this kind of front sheet from a RC car, I think. It's thin and very, very flexible. I think it's actually maybe about as flexible as the HDPE. I'm thinking I might just go the HDPE because I know the material properties of HDPE and it's gonna work. I mean, it will give us a bit of a textured look to the top, which I'm not really all that jazzed about. I would love a like see-through top, but I think that this is just gonna crack and shatter as we try and cut into it and try and do too much to it. So it's probably not the greatest idea to run this as our combat robot piece. Okay, now we face a weird process question. Which do we put on first? The lid or the bar? Because the bar I probably am going to need to be able to pinch from both sides to get enough gription to actually get the lock nut in place, or the lid because it might be a pain to get it in after we put the weapon on. I think I'm going to try the weapon first and see how we go. It should be okay to do it this way around. I've got a little spacer here because it locks down the weapon and gets it to sit exactly where it needs to sit. Come on. Trying to get the bar to lock down because getting enough friction on that bar, on that motor underneath here, is quite a problem, and I need as much as I can get so I can get this lock nut down. Alright, so that was a massive, massive pain. Hopefully that's the last time we have to do that, because damn, I do not want to have to do that again. I mean, although I'm probably going to have to, because let's be honest, this thing is a glass cannon, so I'm expecting everything to break at some point along the line. Let's get the lid on now and yeah, maybe put it in the test box, although I'm kind of tempted to not spin it up until the competition, because then at least that way if it breaks in front of everyone and not just you guys. But I don't know, we'll see. Okay, so we have a thing, and I'm just gonna hold this from underneath. The blade clears with relative ease. Oh, I don't like the sound of the motor kind of sticking a little bit there. Hopefully that's nothing too critical. I might need to put a bit of tape on the back here because it gets a little close there, but it should be okay. Yeah, all right, let's put some wheels on and weigh this thing. Okay, this is something of a moment of truth time. Here we go. Ah! Under by half a gram. Oh my God, okay. That's insane to me, the fact that we are just ever so barely under. Now, we do have a slight issue. That is that the robot is set up to drive forwards, and at the moment, doing so means that the bar is well off the ground. So I'm gonna see if I can use that extra half a gram we have and glue on just a piece of this. I might even just snip the end off and glue this up so that we sit about here. Where can we sit to? We can sit all the way down to there. We don't want to sit that high off the ground though. We do want to have this as flat as possible. Yeah, I mean, we could sit there, but I don't want to. And also, we can't put that whole, this whole skid on, because that is definitely going to make us overweight. And with something like this, we are not going to get any leniency on the weight bonus here. We are, or on the weight of the robot here. We are going to have to run this as close to the books as we possibly can, because, yeah, This thing is ridiculous. Okay, that was as cool as it was concerning. This is an interesting beast of a little machine. So when I drive, the whole robot tilts forwards a little bit. I probably should have had the wheels slightly further forwards than they are. They are kind of just offline with the weapon at this point in time. I probably need to adjust the tilt a little bit too, because while the weapon is spinning, if I move at all, the weapon hits the ground. So I probably need to trim down my little skid standoff at the bottom here before I go into a competition, because I think being able to move is going to be important, especially when it takes 10 seconds for the weapon to spin up properly, and I need to sit the weapon really low, and then it kind of like ekes and ekes and ekes and then spins and slowly, finally, eventually gets going. Once it gets going though, it's terrifying and does not slow down for a long time. So this is going to be an interesting little robot to fight with. Oh man, what the hell is going to happen? Oh, this is going to be wild. I am not expecting this to do well, by the way. I am expecting this to go into one fight, spin up, and destroy itself. And if it doesn't destroy itself, it's going to throw itself out of the arena multiple times. So do not expect big things out of this other than big hits, because big hits is the thing we are going to get out of this particular robot. I will tune this up a little bit off camera. Like I said, I think just adjust the angle that everything's sitting at a little bit, just to get everything kind of sitting nicely. But yeah, we are pretty good on this one. This robot is basically complete. Before we end though, I will say a huge thank you to the HiJinx team and also to Fingertech for actually making this awesome looking bar. This whole design would not have come to fruition without that being the catalyst. Jen from Team HiJinx has a YouTube channel. I will link that in the description down below. So if you want to see more HiJinxy type stuff, check that out. And yeah, that'll be it. If you want to see this little thing fight, there will be a fight recap coming really soon. So subscribe and I will see you in that video.